Stochastic differential equations, we normally write them in short as SDE. In this video, I'm going to construct an SDE object to represent a univariate Brownian motion of the form dx is equals to 0.2x dt plus 0.4x dw, where w there is representing Brownian motion. So in some texts, it's written as a b, but when we're in Matlab here, we write it as a w. What we have looked at before were ordinary differential equations, and you said ordinary differential equations, they can model anything which varies with time. But incorporating randomness or white noise in the coefficients of the ODE gives us a more realistic result, of which in most cases we want a result which is more realistic, so we have to introduce some white noise or randomness, of which when you do that, we then come up with the stochastic differential equations. So the first step of creating the SDE object, I'll click on the return key and then click on code. We want to write our SDE in the form dx is equals to f dt plus g dw. So we start by creating the drift and diffusion functions. For the drift function, we'll call it an f is equals to, and then we type in at the sign, then open parenthesis. And then we are saying that f is a function of t and x, so is t, then comma, then we put an x. So for the t there, it's 0.2x. So I will then put the arrow there, and then it's 0.2, then multiplied by the x. So that's the f there. And then I put a semicolon just to suppress this, then click on the return key, then enter the diffusion function, which I'll call the g is equals to, and then then open parenthesis, and it's a function of t and x. Then we are looking at now this function here, 0.4x. So I'll type in the 0.4, then multiplied by x, and then put the semicolon there. So I can just run so that our f and g are captured in the drift and diffusion functions. And then I click on the return key. I'll now go on and pass these functions to the SDE object. So what I will type in there is the object that we are creating, or bj, just in short, is equals to SDE, and then open parenthesis, and we are putting the f of the drift function, then the diffusion function, the g, and then I can go on and run. And we have the result here coming out on the right there. I can just shift this one so that it comes out clearly. So the SDE object that we're having is one state Brownian, and the start state is a 1, and the drift rate function is the f, the diffusion function is the g. An SDE object enables the simulation of vector valued SDEs.